at a particular beach depends on the temperature. So you can see down here, as the temperature goes up, the number of people who attend this beach also goes up, and it looks like it's linear. So what we want to do is draw a line of best fit here. And so the line of best fit simply is that goes through the data as fast as possible. So there's an equal number of points above the line and below. And so I'm going to draw a line something like that. And again, I want to make sure that there's 1, 2, 3, 4, 5 points. Looks like above the line, 1, 2, 3, 4 points below the line. It's pretty even. It looks like it's going through the center of the data, and it looks like it's creating the trend. It's not going down to the right, it's going up to the right. And so what I want to do then is use this line that I've drawn, which is a line that I just kind of drew by hand. And I want to pick 2 points that are kind of far apart on that line. For example, I'm going to pick these 2 points. And then what I want to do is use those 2 points to write an equation of this line of best fit, or this trend line that I've drawn. And so I'm going to go ahead and pick these 2 points. It looks like the first point, which is the one down here, is 82. And so I'm going to label that point 82. And I don't know exactly what this point is, but it looks like we have from 75 to 150. So I'm going to guess that this point, which is about this level here, is probably close to 90. So in other words, when the temperature is, maybe that's even close to 100. I'm going to say that's close to 100. When the temperature is 82 degrees, there are about 100 visitors to this particular beach. Then if I find the other point, that's this point here, it looks like that's 94. So when when it's 94 degrees, the number of people that go to the beach is about 600. So what we want to do is use these 2 points to write an equation of this line so that we can make predictions about when the temperature is a certain temperature, how many people go to the beach. So we've done this many times before. That's 600 minus 100 over x2 minus x1, and that's 94. So 600 minus 100 is 500. 94 minus 82 is 12. And so let's take 500 divided by 12 to get my slope. It's 41.6 repeated to 42. So the slope in this case, remember, is the y per the x. So that means the y is the visitors, the x is the temperature, or the degrees. And so we get 42 more visitors to the beach with every degree that it's warmer outside. That's what the slope is. So now what I want to do is write an equation of the line. So I'm going to use y minus y1 equals m times x minus x1. This is something you should remember from the first semester. I'm going to pick one of these points. The point I'm going to pick is the first one. It's going to be y minus the y value, which is 100. That equals the slope, which is 42, times x minus the x value, which is 82. So I'm going to have y minus 100 equals, if I distribute the 42, it's going to be 42x minus, I'm going to take 42 times 82, that's minus 3,444. So then if I add 100 to both sides, I'll get y equals 42x minus 3,344. Now, y-intercept here is kind of an interesting one, because that would mean that if it's 0 degrees outside, our y-intercept would be that negative 3,344 people go to the beach. So obviously that's not plausible with our situation. Most of the time, linear equations work for a period of time, but then if they're extrapolated forward, that means if you take the time and move it ahead too far or back too far, it's just not going to be a viable equation. But it does work in the points in the range that we're talking about here, 4 about 80 degrees to 96 degrees. So we can make an assumption, and again, it's an assumption that this would also work a little bit more, a little bit hotter than 96 degrees, or maybe a little bit less than 80 degrees. But it's probably not going to be a correct equation to use if we want to figure out how many people are on the beach at 0 degrees or even 20 degrees or something like that. So this is what mathematicians do to make predictions, though. And so now we have this equation. Now we can make a prediction. And the first prediction that we're going to ask is this: how many visitors would come on a 100-degree day? So if we assume that this trend is going to continue at least 4 more degrees, we want to figure out how many visitors would come. We're going to use our equation to do that. Remember, x is the temperature, and y is the number of visitors. So if it's a 100-degree day, I'm going to let 100, I'm going to substitute 100 in for x. My equation is going to look like this. I will have y equals 42, but not times x, it's going to be times 100. And then minus, that's minus 3,344 people. And so 42 times 100 is 4,200. If I subtract 3,344, I'm going to have 856 people attending the beach on a 100-degree day. So this is something that maybe you are a vendor and you want to go sell things to people on the beach. It's 100 degrees. There's going to be about 856 people there. Maybe you're just somebody who wants to go to the beach, but you don't want to be there. It's too crowded. So maybe you want to go if it's 100 degrees, but if you find out that there's probably only 856 people, maybe you don't want to go. So anyway, there's a whole bunch of reasons why you might want this information. The math behind it is a valuable tool to have, not only in this situation, but many others like it. Your homework assignment for tomorrow is 4 situations very similar to this one, where you're going to have to draw a line of best fit, and then pick 2 points not too close to each other, because if they're too close to each other, it's going to be off a lot quicker as you move to the right or to the left. Once you pick your 2 points, find your slope. Once you find your slope, use the point slope to write your equation, and then you can use your equation to make predictions. That's what the homework assignment is for today. Good luck on that, and we'll see you tomorrow.